Hello everybody! Today I'm going to continue the explanations I started in the earlier video on the first three problems, but now with the next two problems from the educational code forces round 161, the problems D and D. Now in the problem D we have n monsters and we want to check if we want to simulate a fight basically. So at each round we want to check if each monster dies based on the damage they get in this round, and then we also want to be able to properly simulate this process in such a way that it will be fast enough. So now let's think about what would mean for a monster to die. So basically we can start with this brute force solution where for each monster we can check if the two monsters before it are dealing enough damage for this monster to die, and we can have this run in n squared. And of course this is not fast enough, but it's a good start. However, we now want to speed up this process. So basically we can continue from the observations we made so far to get to a faster solution. So basically, let's analyze what happens when we have three monsters, A, B, and C, and B is killed. So let's say that A and C deal enough damage for B to be killed. Now, what happens is that if we kill this monster, then what will happen is that now after this happens, A and C will become adjacent. So basically we can now rewrite this array as something that has A, C, and everything else. And what happens is that if we know what monsters we killed in a round, we also know what monsters we really have to check in the next round. Because what happens is that if we have, let's say, a monster that was not killed in the round and no monster next to it was also killed, then there is no point in checking the same thing and getting to the same outcome. So this gives us the idea of running some sort of a simulation where basically we brute force the first round to see what monsters would get killed, and then for each subsequent round, if let's say we killed a monster in the round before, we can just check the monsters that are next to the killed monsters. And I'm not sure if you noticed it by now, but this is very similar to something like a BFS. Like for example, if we have these values from here, I don't know, let's say values from 1 to 8, and we now have these two positions that were killed. By removing these, we can just check these two, and also 5. And also, let's say if 3 gets killed, we can just check 2 in the next round, but we don't have to check 5 and 7 anymore, because they are now not relevant anymore. So we can keep checking and do this in a manner similar to BFS. And the nice thing about this is that the complexity will actually also be very fast. So it's gonna be something like n log n, because you also have to insert things in a set. So as you can see in this submission, I just brute force the first round to see whoever gets killed. And then for every other round, I had a set where I kept the positions that had some sort of a change. And now for each next position, we now want to find the previous position to it and the next position to it. This can be done in many ways. We can use something like lower bounds, upper bounds, and things like that. But at the same time, the faster way is to just use something like in a linked list. So we start by having the previous and the next position as being I-1 and I+1. This technique was also featured in a problem in Hello 2024, by the way, so it's actually something that shows up quite often these days. And every time we kill a monster, we take these two positions and we basically connect them together, but also insert them in the positions that are worth checking for the next round. So, and then here we do the checking in a similar fashion to what we did here. You should be careful to not count as the same position twice, because we can only kill a monster once. But this problem is actually a very nice example of us simulating the process in such a way that we can optimize it very easily. Now, the fifth problem from the contest, and I would say this was actually a problem that was easier than its actual position, was problem E. In problem E, we were given an integer x, and we wanted to find an array of length at most 200 such that it has exactly x increasing subsequences. Now, this problem actually was somewhat well known for people who are more familiar with Olympiads, although I didn't use that Olympia problem in order to solve this one, as I managed to came up with the solution very fast, and I'm going to show you how to do exactly the same thing too. So we have to find an array that has exactly x increasing subsequences. Now let's start with some, let's say, corner cases, or let's say some easier cases. If we have an increasing array, let's say we have something like 1, 2, 3, 4, and so on, the number of increasing subsequences is always going to be equal to 2 at n, where n is the length of the array. The reasoning is simple. This is the number of subsets we can choose from this array. So basically, if we have 5 values, we would have 32 subsets. Now, how can we use this in order to get our answer? So now let's also bring in discussion the binary representation of the answer, or the number of sequences we need to get. So let's say we need to find something like 23 subsequences, or even better, something like 28, to also have some sort of a gap in the binary representation. So as you know, 28 in binary is equal to 16 plus 8 plus 4. So again, let's say with 29 we would have also had a 1 or something. So we can start by constructing something with 16 subsequences. This is fairly easy. 1, 2, 3, 4. An array of length 4 which is increasing and has 16 subsequences. Now, how do we get another 8 out of this? So we basically want to also find something that has something to do with powers of 2, but also to avoid, let's say, overcounting. We can also have something like, let's say in theory 1 to 3, that would be another 8, but the problem is that we would also have many other that will form like 1, 1, 2, or 2, 2, 3, and so on. Another alternative would be to start counting things in backwards, and we would have something like 4, 5, 6, 7, 1, 2, 3. But the problem with this approach is that the length would be too big, as we need the length to be at most 200. Because in worst case, we would have something like 60 plus 59 plus 58, and this grows fast. Now, let's discard this idea. However, we can use something better. We can now take values in decreasing order. So basically, if we know the power of 2, up to which we need to go to, this is also going to be the power of 2 we are going to use in our answer. So for 8, now that we already had the 16, we can just add another 4. And it would only match these 3 values with the 4. And we know already that here we have 8 subsequences. And the same for 4. We can now have a 3. And it would work once again with 1 and 2. And this is the way you can use to get a very fast solution, and also something very easy to implement. I managed to implement it in less than 10 minutes when I first solved this problem, and also now when I submitted it. So let me show you the solution. So I just found the powers of 2, the greatest power of 2 up to n. And then I found the first part of the answer, only to then follow up with constructing the answer in reversed order. So as you can see, I repeated the same thing here to make sure that I properly compute the nearest power of 2. There is no point in binary searching over this because the array is already supposed to be small enough. So after that, I just printed the array, and it was a very straightforward accepted solution. And you also can solve problems like that in very few minutes if you know what you're doing and your intuition is strong enough. So yeah, these were the problems, the solutions for the first 5 problems from the educational round. The last problem is some sort of a more complicated range DP. I think the editorial is going to be published soon. But if you enjoyed watching this video, please like the video, subscribe to the channel, and share the content to your friends. It helps me a lot, especially in this highly competitive environment, as you can, as you want to watch the very best content creators, and you can watch here the best content out there. So once again, please share the video and make sure that it reaches each and every one of you. So once again, thanks for joining this video. You will find other recommendations in the description, and see you soon. Cheers.